Now Einstein returns to a simple image he first imagined in high school. What would happen if he ran as fast as a wave of light?
Both Isaac Newton and Einstein shared this uncanny ability to create simple pictures that children could understand and extract from that images which changed the universe.
According to Newton, the speed of a light beam should appear slower to someone who runs alongside it. But light does not seem to obey Newton's laws.
Einstein says the light beam moves away from you at the speed of light, no matter how fast you move. You can never catch up the light beam. You hit the accelerator, you gun the engine, the light beam still moves away from you at the same rate. How's that possible? How is it possible you can never catch up to a light beam?
Now, like Galileo and Newton before him, Einstein ruthlessly questions assumptions that no one else dares. If the speed of light never changes, then something else must give.
Then he had it. Time is relative. Time is relative to the speed at which you move. And that idea shook the universe.
Einstein has discovered that Newton's laws only hold true for the world of everyday experience. When objects travel at speeds close to the speed of light, common sense breaks down. Distances stretch. And clocks tick more slowly. Newton, forgive me, Einstein writes later. At the age of just 26, he topples Newton's laws of motion with his theory of special relativity. With childlike questions and simple pictures, Einstein changed the world. In 1907, Einstein turns to new scientific challenges. But newly published letters reveal a little-known personal side. As he creates his greatest work, he will withdraw within himself, and those closest to him will suffer. Einstein's wife, Mileva, was once a physics student who dreamed of her own scientific achievements. But now, as Einstein lectures and collaborates with others, Mileva hardly sees him. She fears she is losing both her husband and her dream. Then, in 1914, Mileva discovers that she has a romantic rival, Elsa Lowenthal, Einstein's cousin. Einstein's marriage falls apart.
You know, I'd love to have a beer with Einstein, but I wouldn't introduce him to my sister. There was a sense where the rules didn't necessarily have to apply to him.
Einstein will marry Elsa, who's willing to keep house for him with fewer expectations. He's given up on love in marriage. His science comes before all else. By age 35, Einstein is pursuing a goal many physicists believe is impossible. His intuition tells him that there must be a more general theory of relativity that also explains the force of gravity. Like Newton, Einstein is obsessed. For years, he grapples with mathematics of horrendous complexity, unsure whether he is on the right path or a fool's errand.
He famously would worry a problem for years on end, almost like a dog with a bone. Wouldn't let go of the problem.
When he was working out general relativity, he almost had a nervous breakdown. He would concentrate to the point that he lost an enormous amount of weight. He wouldn't eat. He focused on a problem the same way that Isaac Newton focused on a problem.
At last, In the fall of 1915, Einstein realizes he's solved it. His great insight is so strange, even physicists will struggle to comprehend it. He proves mathematically that mass and energy curve space and time. A massive object like the sun warps space and time so much that a nearby planet moves in a curved path around it. To Newton, they appeared to be attracted by a force. But this is just an illusion. The same phenomena holds true on Earth. Objects that appear to be pulled by a gravitational force are actually traveling through warped space-time.
Einstein's general theory of relativity changed forever our ideas about space and time. It is so beautiful, it has to be right.
Einstein arrives at a set of equations governing space-time curvature. These simple lines describe the motion of galaxies and the destiny of the universe.
When we physicists look at the equations of Albert Einstein, we cry. We cry because they are so gorgeous. Realize that the motion of the heavens, with all the curved spaces and time warps and what have you, can be summarized in an equation about an inch long. That is power. That is incredible. That is beautiful.
Although Einstein will continue working until the day he dies, by the time he is 40, he has completed his greatest work. Galileo applied mathematics to motion. Newton perfected these laws for everyday experience. But Einstein's search for a deeper theory revealed laws that govern the entire universe. Today, another brilliant rebel is searching for an even broader theory, a theory of everything. No living scientist has shaken the foundations of physics like Galileo, Newton, or Einstein. But among those who have advanced cosmology's frontiers is a once lazy student named Stephen Hawking. Today, he holds the same chair in mathematics at Cambridge University as Isaac Newton.
I was born 300 years after the death of Galileo. I hold the same job at Cambridge as Newton did, and I work on Einstein's general theory of relativity. Of the three, I feel closest to Galileo. He followed his nose and was a bit of a rebel.
Stephen Hawking is born in 1942 in Oxford, England. Like Galileo, Newton, and Einstein, as a child, he is fascinated by how things work. Yet at Oxford University, Hawking hardly works at all. Instead, he relies on his extraordinary facility with mathematics to coast through. Hawking spends most of his time socializing and on the river with his rowing team.
By all accounts, Stephen Hawking was not the kind of person destined for greatness.
At college, Stephen was not the hardest of workers. Stephen himself says that in his entire undergraduate period at Oxford, he only worked about 1,000 hours, which is an hour a day on average.
Hawking is bored and apathetic. Nothing seems worth working for. Yet a tragedy is about to strike that will turn a bored intellect into a passionate mind. In 1962, Stephen Hawking has just begun to study cosmology as a graduate student at Cambridge University. But